In this recording, we're going to learn how to use those log properties that you just learned about. We're going to do two things with them. We're going to be able to expand log expressions and also simplify them. Now you might say, why would I ever want to expand? Why would I want to make something less simple, or more complicated than it is? Well, the reason is it's sometimes useful to use log properties to extract a particular part of a log expression using log properties when we solve equations. So let's tackle this together. First example, we've got log base 4 of 6 to the x times n. And we're going to use our properties to expand this out. First thing is, how many factors are there? Well, there's 6 to the x and there's n. There's two factors. So what that means is I'm going to end up writing the word log twice. And anytime I write log, I have to write what the base is. So log base 4, log base 4. I would encourage you to think of it in this manner. Two factors, that means two log terms, just like in our product rule, there were two factors, two log terms that were being added. Two factors here, r and s, two log terms. The one in the denominator, the s, became the negative. Okay, just like a negative exponent goes to the denominator. All right, so I've got here 6 to the x and n. All right. And I think I can apply another property. Remember our power rule? We said if you have an exponent, you bring it down in front. So that's what we're going to do here. Bring it down in front. So I've got x log base 4 of 6, just before, x log base 4. Can't seem to make that. I'm going to give it one more try. Of 6 plus log base 4 of n. Okay. Next example. This one's complicated, but we can handle it. Let's break it down into small chunks. How many factors are there? I see 1, 2, 3, 4. Okay, that means we're going to write log 4 times. So let's do it. Log base m, leave a little space. Log base m, leave a little space. Log base m, leave a little space. And log base m. Now, the other important consideration is, are there going to be any negative terms in here? Remember, there are negative terms when we have log of a quotient. I don't see a quotient, therefore there are not going to be any negative terms. They're all going to be added up, right? So I've got log base m of 6 to the x plus log base m of y squared plus log base m of z cubed plus log base m of m. Well, in our final analysis, we can bring exponents down in front. Okay, and hopefully you're getting good at this. And if you say to me, couldn't I have skipped this step? I know what I'm doing. Can I skip that middle step? Awesome. Skip the middle step if you know what you're doing. Okay? The 2 comes down in front. 2 log base m of y. 3 comes down in front. Log base m of z. Hey, wait a second. Log base m of m, it's the same thing. Couldn't I say, I think I had a property like that. The base and the argument are the same. That's a 1, right? So couldn't I be clever here and just say that's a 1? You sure could. All right, so circle our final form because we're showing steps. All right. Let's get a little more complicated. We're going to get two other examples that are a tiny bit more complicated. This one's got a fraction in it. Okay, no problem. Count the factors. 1, 2, 3, 4. I'm going to be writing log 4 times. So log base v, log base v, log base v, log base v. Okay. Now, 4 and a are in the numerator, so they are going to be positive. 5 and b are in the denominator. They're both in the denominator, so they're both going to be negative. All right. An alternative way of you could have written it would have been this. This would be acceptable. Log base v of 4 plus log base v. You don't have to write this, but just know that it is also fine if it occurred to you. Okay, see if you can take this in and see how these are mathematically equivalent. I could distribute this negative sign to end up what's above. I could factor out the negative sign to end up what's below. You could think of the 5 being multiplied by the b, which is why here I have a plus sign. That would imply that they're both being multiplied, but they're both in the denominator, which is why I'm subtracting their whole expression. Otherwise, up here you could think of them both being separately in the denominator. Either way is fine. Just put an or here. Alternate versions. Okay, either one's good. Last example of this sort. It's a doozy. Whoa, crazy. All right, let's break it down into small chunks. 1, 2, 3, 4, 5 factors. All right, I'm going to be writing log 5 times. It always has a base. So log base 2, 5 times. Okay. Are there any negatives? Yes, there are, because we've got fractions in the argument. So let's start slow. Log base 2 of the square root of 8. Okay? Plus log base 2 of a cubed. Plus log base 2 of b. And here's where we're going to get our negative involved. Minus log base 2 of c minus log base 2 of d to the second power. Now, you might recall that when we have a square root, that's the same as saying 8 to the 1/2 exponent. Okay, now I've got everything written with exponents. I can bring those exponents down in front. So our final form looks like this. Half log base 2 of 8 plus 3, bringing that exponent down in front, 3 log base 2 of a. Well, this one doesn't have any exponents, so no further work needed. This one doesn't either, but it's a minus. This one does. Minus 2 log base 2 of d. All right, so that's pretty much as hard as they would be for us to expand those out. Remember, number of factors equals number of terms. Negatives are for when we have denominators. Let's write some notes to ourselves. All right, I encourage you to write these hints. When we're expanding out log expressions, kind of think of an order of operations this way, just like we just did in that last example. If you have any radicals, we'll turn those into fractional exponents, just like we had 8 to the 1/2 was the same as radical 8. Separate the factors into log terms. Remember, we're counting the number of factors. We said in the previous example, you've got 1, 2, 3, 4, 5 factors that led to 5 log terms. Always write the base with the log 2. And then bring the exponents down in front. Recall we did that? Okay, we took the 3 down in front, didn't have it, brought the 2 down in front. Things to check. The number of factors in the log expression has to equal the number of expanded log terms. Finally, factors in the numerator are positive terms. Factors in the denominator should be negative terms. We saw it in our last example. The c and the d squared had negative log terms. Okay? Well, simplifying is actually a whole lot easier. So let's write this down. We're going to do these 4 examples together, simplifying using your log properties. And basically just reverse the order of operations. Okay, so in the first example, we're only going to need to write log once. Log. Okay? Everything's being added, so that should imply multiplication, right? But the 2 comes up as the exponent of the a. Notice only of the a. So log of a squared. Then b and c, these are terms are being added. It's like our product property. So log of a squared bc. Next one. Well, I could put it like a -1 here if I like. Put a -1. All right. This one has a natural log in it. The previous one, common log, right? Could write a base of 10 or not, your choice. This one, if it has some negative terms, that means we're going to have log with a fraction in it. Okay, so I think I might do this one like this. I've got log. Why do I have log? It should be this. I have natural log. That's better. If you wrote log base e, that would be cool. But, all right, where's this one going to go? It has a negative 1 as its exponent. So, because it's negative, it's going to be in the denominator. X to the 1. If you don't want to write the 1, you don't have to. Next term is a positive term. The 2 comes up as w's exponent, w squared. And this one's negative. So the 3 is going to come up as y's exponent, but it's in the denominator because it's negative. All right. A little tricky there with the negatives. Hopefully you got that. 2 more. All right, I looked this over. I've got some negatives, so I know I'm going to need a fraction. So let's make it log base 4 of a fraction. Now, 5 is a argument of a positive term that's going to be up in the numerator. M is in the denominator because it's a negative term. This 2, remember that comes up, n squared. So 5n squared on the top, m on the bottom. Okay? Last one I'd like you to consider. This one's pretty complicated. I don't see any negatives, though. Don't have to worry about that. So it's just log. Well, half. Remember, half comes up, but that means square root, right? Square root of a. So I've got log of the square root of a. And by the way, it's base 6. Square root of a. This 3 comes up, and it applies to both of these factors. So it's going to be, in parentheses, 4c cubed. Tough stuff. You'll get it with lots of practice. We'll get that practice in class. Thanks for watching. Now try the quiz.